In this video I'm going to talk you through how to calculate the true airspeed. Okay, so let's look at the basic formula. It's really not terribly complicated. Okay, so true airspeed is equal to the EAS, the equivalent airspeed, times the square root of this rho naught over rho. So this is the density at some altitude, and this is density at sea level, and this is the equivalent airspeed. Right, so if you know the equivalent airspeed and you know what altitude you're flying at, you can work out what the true airspeed is from this data. And you use the IAS, International Standard Atmosphere, and in the International Standard Atmosphere, rho naught is equal to 1.225 kilograms meter cubed, and this is at sea level. The rho naught is density at sea level, and this is 1.225, just use that number. You can convert this into other units if you so require, but make sure that you're working in consistent units. So this is a ratio and it'll cancel on density. Anyway, so if you want to get rho, you look up in a table, for example, at some temperature and some pressure, you'll get some value. For example, rho equals 0.7708 at 258 Kelvin at 15,000 feet. Okay, so if you do the calculation, you get true airspeed. Let's say that equivalent airspeed equals 100 meters per second. So true airspeed would be 100 times the square root of 1.225, that's our rho naught, divided by 0.7708, and that would give us a true airspeed of 126 meters per second. So there's a basic calculation. So you need to get the International Standard Atmosphere tables. You can look those up very easily on Google. Rho naught is always this, and this is the equation. I'll just quickly show you for high speed, there's different equations. So if you're dealing with something flying very fast, so over Mach 1, you'd best to look at the true airspeed is about 39 times the Mach number of the square root of temperature for knots. So if you've got, if you're working in knots, you can use this formula. Otherwise, you can derive one, which is the square root of gamma r times the Mach number times the square root of t. This gamma is about 1.4 at 20 degrees for dry air. And this R you can take as 287 joules per kilogram per Kelvin, and this is of course derived from the fact that A, the local speed of sound, equals gamma RT, so you can work this equation from other equations online. If you've got high speed, these are the relationships you should use. If you're working in knots, you can use this formula, or you can use this formula, work in consistent units. This has been derived from various assumptions. Okay, so that's how you calculate the true airspeed of an aircraft flying subsonic or at high speed. Hopefully this is helpful to you, and thank you for watching.